So let's talk about present and future worth analysis.
So, for the present worth analysis, normally used for two types of projects, which is mutually exclusive and independent. So in this case, we have an interest that used in this present worth analysis, which is to convert the cash flows into equivalent worth at some point of time, which is known also as hurdle rate. This is actually MARR, which is known as the minimum attractive rate of return. So this analysis is actually a measure on how the money can be afforded in the investment in the excess of cost. So as you can see here, the three economic criteria is reinstated in the present worth technique, which is known as the fixed input, fixed output, and neither fixed. So now we're going to go through the three different analysis period situation that is shown in the multiple alternatives. So for the present worth analysis, we're going to look on first case, which is the four equal alternatives. So when there's two or more options, the present worth PV will be using the MAR, right? So we will evaluate two alternatives and choose the one with the highest difference between the present worth of benefits and the present worth of costs. This measure, which is known as the present worth of benefits minus the present worth of costs, is known as the net present worth, which is known as the NPW criterion. So let's say for the projects which have different durations, such as 3 years and 5 years, the PW for alternatives must be evaluated over the identical time span. So how can be done is we can maybe compare the alternatives over a period which is equivalent to the least common multiple of their lifespan, which is known as the LCM. How we do this is by comparing the alternatives with using the study period with the specified number of years, such as X years, which in this case can be also be done like say 3 years or 5 years. Then we have something called the infinite analysis period, where this is, let's say for governmental analysis, like certain services or conditions, right? You need require analysis for a long period of time, which is called indefinite time. So this necessity is for infrastructures like roads, dams, pipelines. It seems permanent, right? So in this situation, the present worth analysis should be done in an infinite analysis period. We call the particular analysis as capitalized cost. So we have a formula for it, which is capitalized cost is equivalent to P equal to A slash I, where the N is equal to infinite at the end of period withdrawal, where A is equivalent to IP for each period of A equals to PI. Last but not least, we have the multiple alternatives, where when multiple alternatives are available, we typically compare them in a single table, as you can see based on the example. This goal is to determine a single table that automates as many as calculations as possible. With that being said, that is the actual typical analysis done for the present worth analysis. Now we're going to look on the future worth analysis, where it's almost similar to the present worth analysis, but we are dealing with then, which is the future worth, than the current now, which is the situations. So what will the future situation be if you take a particular course of action now? That's why we are going to use this analysis to find out. So the future worth can be determined by directly multiplying the cash flows by the F/V factor. By the same time, we also can do it by technically by multiplying the PW, which is the present worth, by the F/P factor. So this future worth is especially used for large capital investment, where the main goal is to maximize future wealth of the company, means technically futurized. So for the asset that might be sold before the expected lives are reached, and for projects that will not be coming online until the end of investment, such as toll roads, hotels, and etc. So we are targeting to have the FW more than 0, means the MARR, which is the, as I said before, has been met. But this is for one alternative, yeah. So this kind of future worth analysis is more towards mutually exclusive projects, where we have to select the highest numerical future worth. With all that we said, thank you.
So what is EUAC and EUAB? Let's take a look. EUAC is the equivalent uniform annual cost, which is the average yearly cost of owning and using something throughout our entire life. It includes buying, taking care of it, using it, which can be turned into a yearly amount. Now let's see what is EUAB. EUAB is the equivalent uniform annual benefits. The average yearly benefit you get from something, spread out evenly over its entire life. It includes all the money you make or save from it, turned into a yearly amount. Now let's take a look on the annual cash flow calculations resolving a present cost to an annual cost. One is with salvage value and one is without the salvage value. So first off is the purpose. One is to convert the present value to equivalent uniform annual worth. Another one is to adjust the EUAW for salvage value at the end of the period. The output is the same, which is the equivalent uniform annual rate. As for the formula for the basic one, without the salvage value doesn't have the sinking fund factor, which is the F. As for the salvage, we do have the sinking fund factor. The advantage of the basic conversion formula is to simplify the comparison by converting present value to uniform annual amount. As for with the salvage value, it accounts for the future value, providing a more accurate EUAW considering the asset's lifespan. So for which case, basic formula is used when there is no salvage value at the end of the period. And for the formula with salvage value is when there is salvage value remaining at the end of the period. We may wonder why we have to include the salvage value, the treatment of the salvage value to the overall process. This adjustment accounts for both initial cost and the salvage value to provide a yearly equivalent cost. The advantage of it is it provides a comprehensive view of the project cost, considering both upfront and at the end of the life value. When is the case is when assessing projects with assets that have a residual value at the end of their useful life. As we can see here, these are the three formulas that can be used and applied depending on the questions given. And for this example, we are applying the first equations, where there is sinking fund value being substituted into the S formula and the annual present worth value at the beginning of it. So the I stands for the interest, N is the number of years, F is the sinking factor, and substituting them all in, we'll get a sum of $127.92. Moving on to the annual cash flow, three essential points needed. First off is the equivalent uniform annual worth, which is known as EUAW, and EUAW and the cost, and as well the third point will be the EUAW and the benefits. The EUAW represents the difference between the equivalent uniform annual benefit and equivalent uniform annual cost. As we can see here in this equation, the EUAW is found by minusing EUAW with EUAC. The EUAC is when there is a cost associated with the project, the EUAW decreases. This indicates the potential net loss. As for the benefit is what the EUAW gains, so what the potential it has to increase. In this example 6.5, there are two devices. With device A, with only EUAW and the cost, where it indicates a potential net loss. As for device B, it has a $50 increment annually. After doing the calculations, we found out that device A has an EUAW worth of $56.1. As for device B, it is $64. Therefore, it is clearly proven to maximize the EUAW is with the benefits, we have to choose device B.
Hi, I am Go, ID number KA21095, and now I'll be taking over for part 3, payback period, sensitivity, and break-even analysis. Firstly, what is payback period? Payback period is defined as the period required for the profit or other benefits of an investment to be equal to the cost of the investment. It is an approximate which includes all benefit before payback regardless of the time, which ignores economic consequences after payback period. Payback period is important because most firms value this metric because a quicker payback means the fund can be reused sooner for other purposes. Moving on to the calculations, for non-uniform annual profit or benefit, we need to prepare a cumulative cash flow to identify the payback period where the first positive cumulative cash flow is the payback period in years. As for the uniform annual profit or benefit, we can calculate the payback period by dividing the investment cost with the uniform annual profit. Next, discounted payback period is defined as the period to recover initial investment plus interest. We calculate it by preparing a cumulative discounted cash flow. Unlike normal payback period, we consider the time value of money as it includes the interest. The screening guideline is based on the payback period being less than or equal to some specific payback period. If it is, the project will be considered for further analysis. To do the calculation, we can refer to the diagram on the right. The cost of funds is calculated to obtain the cash flow. The formula to calculate cost of fund is by multiplying the unrecovered beginning balance with the interest rate. Now, I will talk about sensitivity analysis. Sensitivity analysis determines how sensitive a decision is to estimates of various parameters. Let's look at an example question which compares the construction method between construct full capacity and construct in 2 stages. By calculating the present worth of cost for both alternatives and plotting it into a graph, it is obtained that the break-even point where both solutions have the same present worth is at 15 years. We can then make the decision based on the time requirement. If we need a project before 15 years, one stage will be preferred, while if we need it after 15 years, two-stage construction will be preferred. That is all from me. Thank you.
Hi, I'm Agilan. So now let's look on part 4, which is rate of return analysis. The internal rate of return, which is known as IRR, is the interest rate at which the benefit are equivalent to the cost, or the present worth is equivalent to 0. Essentially, the IRR is a critical metric used in the capital budgeting to assess the profitability of the potential investment. It represents the discount rate that makes the net present value of all cash flow from a particular project equal to 0. A higher IRR indicates a more profitable investment, while lower IRR suggests a less attractive opportunity. Investors often compare the IRR to their required rate of return or the cost capital to make informed decisions. There are several ways to find the internal rate of return. The first one is using compound interest table. Second one using try and error method using interpolation. Third one is using numerical method. And last but not least is graphical method. Now let's have a look at the minimum attractive rate of return, which is also known as MARR. The MARR is a minimum return the company will accept on the money it invests. It also usually calculated by the financial analyst in the company and provided to those who evaluate the project. It is the same as the interest rate used for the present worth and annual worth analysis. Furthermore, MARR is more frequently used as a measure of merit in our industry and more accurately called as internal rate of return. Imagine we have a situation where we have to choose between project A and project B. In this case, we have to calculate the difference in internal rate of return. For example, B is preferred to A when the internal rate of return on the difference B minus A exceeds the MARR. Thus, to choose between B and A, rate of return analysis is done by computing the difference in the rate of return on the incremental investment between the project A and project B. If the difference in rate of return is more than MARR, then we have to choose the higher cost alternative. But if the difference in rate of return is lower than MARR, then we have to choose the lower cost alternative. In this example, we have to choose between project A and project B, and we can see that the difference in rate of return is 6.1% and the MARR is 5%. Therefore, higher cost alternative of project B should be selected. That's all from me. Thank you.